Hello class, good afternoon, good evening, hope you're doing well today. Today we are doing 5.1b, which is trigonometric identities with factoring. Our objective is to simplify trig expressions using basic identities and factoring skills. So example 1, all we're going to do is factor and simplify, and we've been practicing factoring for quite a bit now. So hopefully you can recognize when to factor based upon what you've seen in the last couple of weeks. Now, unfortunately, the first one has no factoring in it. I think this example should have gone on another sheet, but it still is good review. So let's go ahead and put a note here that this is review, and it actually doesn't apply to example number 1. What I'm going to do here is I'm going to change this all to sines and cosines. I see a cosecant, a cosine, and a cotangent. And that's just too many different identities or functions to work with. So I'm going to change this to 1 over the sine of theta minus cosine of theta times cotangent is cosine over sine. If I look carefully, I see two denominators that are the same, and I'm excited about that. So I'm going to write 1 over sine minus, this is really cosine over 1, so it's cosine times cosine, which is cosine squared over sine. When I have two denominators that are the same, and I have fractions, and I'm adding or subtracting fractions, I've got my common denominator, I can go ahead and write my denominator together over one fraction. So now we are looking at a Pythagorean identity. 1 minus cosine squared is sine squared divided by sine. When you have two sines on top and one side on the bottom, one of them on the top has to go away and this one's gone. So your final answer is sine of theta. Okay, now it's time to factor and simplify. One of the first things that you need to do, you need to look at the problem and not just start writing. You need to notice how many terms there are. So let's just jot a note up here that you need to look for terms. This one has 2 terms. And so a lot of times when there's 2 terms, you're thinking sum and difference of cubes, difference of squares, or maybe it's just good old GCF, greatest common factor, and that's what it is in this case. We have sines in the first term, and we have sines and one sine in the second term. So your greatest common factor between both terms is the sine of x. When you open your parentheses, you ask yourself sine times what would give me sine cubed? Sine squared x. Sine times what would give me sine cosine squared? Well, you just need the cosine squared part. Hopefully you're looking at this and you're seeing the squared things and you're thinking Pythagorean identity. Sine of x times 1 is sine of x. So that's your first lesson in how factoring can really help you. Here we go. The number of terms in this expression is 2. Is it a sum or difference of cubes? Absolutely not. There's nothing cubed up there. Is it a difference of squares? No, because of the positive sign, has to be GCF. And this problem is really pretty simple. There's a tangent in both terms. So I am going to write tangent of x. Tangent times tangent would give me tangent squared. Oops. I'd follow that up with a plus 2 to get that 2 times tangent of x. Getting a little bit more interesting. Sine squared x plus 5 sine x minus 36. 3 terms. Typically is alluding to the fact that we should use guess and check. Now, those of you that are very nervous about the sine squared and the sine here, there's actually something you can do if you don't like them, but you have to remember to put them back in later. Or maybe this is just a skill that you could use at the beginning of factoring. You could think of sine of x as x squared. Instead of thinking about a trig function, just think back to where you were in algebra 2. You used a lot of x's. Plus 5, replace sine of x with just an x, minus 36. And you guys are incredibly comfortable with this type of factoring. Guess and check x plus 9 times x minus 4. Now, you would need to replace that with sine of x plus 9 and sine of x minus 4. Now, let's do a little foreshadowing here. This is just simplifying an expression. Later on, they will be equations, and we will put equal signs in here. Equals 0, equals 0. And remember or recall from Algebra 2 when you were working with quadratics, you would set this equal to 0 and this equal to 0. Now this problem has no relevance and we should not be setting it equal to 0 because of the numbers. This is just a way to get you started with factoring. So I'm actually going to show what this looks like using the word sine. I know that if I have sine squared, I have sine of x out front. I need to multiply to give me negative 36 and add to get positive 5. So plus 9 minus 5. And you are done. That's what the answer should be. Remember, these zeros here were just a talking point, foreshadowing for things that we're going to do in the future. Part E, cosine cubed t minus 27. Hopefully you're noticing that there are two terms and they both are cubed entities. So it is a difference of cubes. And remember, we've talked about having that memorized. A cubed minus b cubed equals a minus b, keep the sign the same, times a squared plus ab, change that sign, plus b squared. This end result will never be factorable. Otherwise, you would have memorized a different formula. So I think it's essential to identify what it is and then write it so you can see what was cubed. In this case, it was cosine that was cubed. Ask yourself, what do I need to cube to get 27? Well, the answer is 3. So this tells you that your A value is cosine of t and your B value is 3. Okay, here we go. I am going to follow this outline right here that's set in front of me. A minus b would be cosine of t minus 3 times, I need to square my a, cosine squared t, plus b times a, or a times b, but we put the coefficient in front, 3 times the cosine of t, plus b squared. B is 3, 3 squared is 9. And that is what we're looking for. Essentially, you're done. Good job. You're practicing because you might have to use these skills when we're doing proofs later. Looking at the example F, I hope you see two terms and a difference. So it could either be a difference of cubes or a difference of squares. And I hope you guys don't think that it's easy to get cubes out of something to the fourth power. This is a difference of squares. So you write it like a difference of squares. You take sine squared x and square that. That's essentially sine to the fourth. Minus cosine squared x squared. You guys know how to factor a difference of two squares. It's sine of x plus, oh, I messed up. What's inside of here is a sine squared. So it's sine squared of x plus cosine squared x times the quantity sine squared x minus cosine squared x. When I see sines and cosines and squared things, I'm always looking for an identity. Hopefully you've found it already. Put your pencil on one of those two sets that is an identity. Hopefully you put your pencil in this right here. This is a Pythagorean identity. The other one is not. Sine squared plus cosine squared is 1 times sine squared x minus cosine squared x. I would leave this as is. Good job. Two more problems for this section. Really, really important that you look and understand what's going on before you just start writing. If you guys recall in Algebra 2, if you wanted to factor something, it was difficult to factor if if the variables were not the same. So look at this. Pretend that like secant is y. Y squared, let tangent of x be x, plus 3x plus 1. There is no way for you to factor that. So what happens in trigonometry is that you need to try to get all of the terms to be alike. Okay, so what I'm going to jot down here is we're going to get like terms. Now, my question is, I could change tangent. It could be 1 over cotangent. It could be sine over cosine. I look at secant squared, and I'm really happy about secant squared because I think maybe it's a Pythagorean identity. Secant squared x is actually equal to tangent squared of x plus 1. So I'm going to replace this with tangent squared x plus 1. Again, I'm going to make a note that that was a Pythagorean identity. They can help you to move through a problem. So secant squared x got replaced with tangent squared x plus 1. I'm going to drop down the rest of my problem. Then I'm going to simplify. Write this in standard form with the highest exponent first. Tangent squared x plus 3 tangent x plus 1 would be plus 2. Right now, you are looking at a trinomial. And usually with trinomial, we guess and check. So, factoring. Tangent of x, tangent of x. Pretty simple. We need a positive 2. We need a product of positive 2 and a sum of 3 plus 2 plus 1. And you're done. All you have to do is factor right now. Why don't you try h on your own? I'll give you a minute. Or you can hit pause and try h on your own. It's very similar to g. Okay, hopefully you took some time to do this problem on your own. When I look at this problem, I see 3 terms. I am assuming that I need to use the guess and check method because it's a trinomial. I look here at cosecant squared, I see a cotangent, and I feel like I need to do something before I can start factoring. What's nice about this chapter, you guys, is that things tend to work out pretty if you let them. So cosecant squared, you can use a Pythagorean identity, and you can change that to something that involves cotangent. So cosecant squared is equal to cotangent squared theta, cotangent squared x plus 1. That is replaceable right there. Minus cotangent of x minus 3. Writing this in standard form, cotangent squared x minus cotangent of x minus 2. I see a trinomial, guess and check. All my variables are the same. Cotangent of x, cotangent of x. I need to get a product of negative 2 and a sum of negative 1. So I need a negative 2 and a positive 1. And I thought we were done with our problems for today, but we actually have 2 more. Looking at this one, we have 4 terms. That could only mean that we need to factor by grouping. So I am going to take the first group and factor out a GCF. Luckily, there are no changes in here. We have all cosecants. So I'm going to factor out cosecant squared beta. And that would leave me with cosecant of beta minus 1. Now, what happens in factor by grouping is that this symbol is really important, and you need to try to attain this in the second part. So I am going to factor out a negative 1 from the second group. That would leave me with cosecant of beta minus 1. So I did a good job because I have this same factor in the left term and in the right term. Factor by grouping allows you to take out this same term in both of them. So it's cosecant of beta minus 1. And then you are left with these remaining parts. So cosecant squared beta minus 1. You should always continue to look and see if there's anything else that can be done here. You obviously can't do anything with the first one, cosecant of beta minus 1, but this is a difference of two squares. So cosecant of beta minus 1 times cosecant of beta plus 1. And, gosh, if you really wanted to be spectacular, you could write this. You're just practicing factoring. You're doing a great job. Last one. 1 minus sine to the fourth x. I look at this, I see a difference of two terms, so it's two squares. It might help you to write them as squares. So 1 is really 1 squared, and sine to the fourth is really sine squared squared. So I know that I can do a plus b times a minus b. 1 plus sine squared x and 1 minus sine squared x. Whenever I see ones and something squared, I'm always checking my Pythagorean identities. And I know in this case that 1 minus sine squared is equal to cosine squared. So we're going to leave this as 1 plus sine squared x, which cannot be factored, and it is not an identity. And we are going to change 1 minus sine squared to equal cosine squared x. And that's all. Thank you for joining me on Flip This Classroom. And I hope you guys are enjoying this experience. We'll keep working at it. Have a good night.